Hey guys, welcome to Straight Math. What I want to do here in this tutorial video is just quickly go over a nice way to factor a quadratic. So let me go ahead and give you a quadratic equation, and we'll take a quick look at it and then talk about how you go about factoring it. Here's a good one for you. What if you were given x squared plus 10x minus 11 is equal to 0. Well, remember a couple of things about quadratics. So first of all, remember that a quadratic equation represents a parabola. So a parabola is going to cross the x-axis at most twice, right? It could only intersect the x-axis once, in which case both of our factors would be the same. Or it may not intersect our x-axis at all, in which case you would have imaginary solutions, which is a whole different animal, and we won't even worry about that here in this tutorial video. But in this case, what we're going to have here is a quadratic where we will actually get two solutions. So let's go ahead and talk about how you would do that. First, hopefully you guys remember that a quadratic is going to have this general form, a x squared plus bx plus c is equal to 0. And what we've got is we've got the nice kind, right? This is the one that's going to be a little bit easier to deal with because my leading coefficient a is a 1. And that makes our life so much easier. So here's what we're going to do. I need to factor this guy into two binomials. We're going to do the reverse FOIL method. And here's the way it works. You need to find two numbers that multiply to a negative 11 and sum to a positive 10. And fortunately for this one, it's not that difficult because 11 is a prime number. So let's go ahead and find those. I write my two binomials. I go ahead and throw in my x and my x because I know that's all that's needed. X times x gets me my x squared. And we're good to go. But now what I need is to finish these binomials with two numbers, and I need those two numbers when I multiply them together to get me a negative 11. And when I add those two numbers together, they've got to sum to a positive 10. Well, like I said, this is easy. 11 is a prime number. So my only two options are either positive 11 minus 1 or negative 11 and a positive 1. Well, since the 10's got to be positive, it's going to have to be a plus 11. And again, let me remind you of the way this works. What you should be able to do is FOIL these binomials and get right back to what you started with. Let's try a little mental math. FOIL is first, so x times x gets me x squared. Then FOIL, the next one is O, which is outer. X times a negative 1 would be a minus x. In FOIL, I comes next, which is inner. 11 times x would be 11x. And then finally, L in FOIL is last. 11 times a negative 1 is minus 11. Okay, great. So I know where the x squared and the minus 11 comes from, but what about those middle guys? Well, remember, what I got was a negative x and an 11x. Well, 11x minus x, 10x. So what I see is if I were to FOIL this guy out, I would get right back to what I originally started with, and so I know that I factored it correctly. Now, you may be asked to do two things. Either you could be asked to find the factors, which we did, or you may be asked to actually find the solutions, the roots, the x-intercepts. Where does this parabola cross the x-axis? Well, in which case, you just use the zero product property to split these guys up. X plus 11 is equal to 0. X minus 1 is equal to 0. Solve both of those guys for x, and we find that one of my roots is a minus 11, and the other root is going to be a plus 1. And here's what you now know, right? Depending on what you've been asked to find, right? If they asked you to find those roots, what you know is that if you were to graph this parabola on a coordinate plane, one side of your parabola is going to cross the x-axis at minus 11. The other side of your parabola is going to cross the x-axis at a positive 1. These represent your roots or your solutions for this quadratic. Guys, thanks so much for joining me for this tutorial video. I'll see you next time right here on StraightMath.